three, four, five. Okay, how many of us have not? Yeah, I don't see it. Okay, eight. Eight. Awesome. Well, fair enough. I believe one of the reasons you're here as well is to learn how to do these things. I'm going to be speaking about deploying these models. Can you guys see what the models bring? Can you guys see? Because, oh my God. You see black background on the slide. So sorry about that. See black fire. Let me see. It's not like it's the projector. That's that's great. Okay, yes, you know what? I'm going to share the slides so everyone has the slides on their laptop. We all have access to internet, but send notes here. No, all your sports. No, for what? I'm gonna oh, all right, can you guys please scan that? Oh, okay. How about those guys? It's scanned it. Now it's just what should it be? All right, so the link is going to be bit.ly/. Beyond AI product. Just like that. Can we all see that? Yeah, so like once everyone is done, just let me know so I can go back to the slide. So the reason I'm using this stuff, the QR code, is so you can have it on your laptop instead of your phone. In fact, I was going to share that. I didn't want to such a slide. Are we all together? Are we all together? Who is not with us? One person. Who else is not with us? Hold on, LinkedIn. Hold on, LinkedIn. Hold on, LinkedIn. All right. So we're all together, right? Okay. Thank you so much. All right. So scaling AI models on global platform. Unfortunately, because I have to do this from this point, I won't be able to stay video of the room because it's manageable. So first, like the deployment gap, right? Are we still having issues? All right. So for people who have worked with models, you spun something up, you pulled something and made some changes to it, and deployed it back, or you're running something on your local, right? Say you download something from Olama and you're just working, playing around with it. Um, so that in a lot of cases, right, just because of convenience, you leave things in your notebooks or just deploy it locally, right? As you would know, these things can't fail, right? Because you're deploying it on local, it's just something that is test. It's most likely not something that you're right. So how do you bridge the gap between you having these files on your local, um, you deploying having them APIs, right? That you can go to use the API. That's compulsory. Basically, I deploy on your Inspire. Is the actually saying that's the difference. I need to make it like this. That's the thing. Let me not spend too much time in that. First thing, you have a unified UI where you can pretty much do every single thing that you'd like to do in the ML lifecycle. So, if you see your data, generating model, monitoring things that you're deploying, then monitoring the things that you're deploying as well, right? So, it's open, meaning that it's open source. You have access to other models that other people have built, and you can build something on top of those. Uh, and there's standard across board for each of these things. Then serverless, or gives you access to serverless infrastructure, meaning that you can spend more time deploying these models, working with these models, rather than worrying about the infrastructure behind it, what you are deploying on, what's running on, and all those things. This is why I said, to what it was to go with the okay. Next thing, Azure, right? The world-class tools that you have access to from GCP. First is class things. Okay? For anyone that, well, I think that's a GCP is I kind of switch that there. The infrastructure that it takes to run models that we have access to is a lot of compute power. And I'm sure you guys have an idea of, right? It's a lot of compute power that it takes to run each of these things. And to run it in a way that they can scale, they can access all the data sets that they've been access to, and they can run without copy, right? Um, Running on GCP gives you access to two different levels of computation power, right? We all know the typical CPUs, right? But now you have access to GPUs and CPUs right there in the UI, right? So without having to plug in an external hardware, without having to do any other extra step, just by using Google Power Console, you have access to do these things. So for TPUs are being used custom ASICs designed specifically for machine learning and massive set for machine learning. It has massive throughputs for training LLMs. Then GPUs from NVIDIA, um, they give you access to H100s for massive training jobs. Right? Both of them are fully supported, or you can access both of them from GA, from your normal VNs, right, on GCP and from Cloud Run as well, right? I'll go into Cloud Run in a bit. So next thing, what this what this allows you to do is to not reinvent the wheel, right? You don't have to spend time. When you guys saying before, something just changed. When you guys saying before, yeah, it's good now, what allows you to do is not spend time reinventing the wheel. Right? There are a lot of research and a lot of effort has been put in to make your lives as easy as possible. Right. So literally, if you don't want to build the console that I directed into earlier, there's something called the model bank. Right. The model bank gives you access to different models, different foundational models that you can then take and build on top of, work with, customize, or just give your application access can pull that is right. You can also look the console there. So this is the next AI on GCP. And right here you have model data, right, on the panel. The model data, as the word implies, about the store for different models, right? And just go there and you have access. So yeah, why entire training from scratch? Not that you should, right? But in all cases, it's not something that you have to do, right? In as much as these cloud service providers and these technology providers make things so much, right? I'm still of the school of thought that is is valuable to you to learn the underworkings of these fields, right? But it's not every time that you need to, it's not every time that you need to create a model from scratch, right? The ML engineers used to do pre 2022 and 2021 back, right? You don't have to every time. You have the option of just plugging into something that's already existing, that's already working, already very functional, and making use of it. Right. So these are just a couple of models that we have there. As you can already see the screenshot from my Power Console Gemini 3, Vision 4, 3, number 3, 4, 3.5, and all the stakeholders. Right. The next development. So for for the development of these models or for fine tuning of models, can make use of something called Google Colab books that gives you access to not only work on these models, but then um, make use of other Google Cloud services right there, um, right there in your UI. Right, it's secure, it allows you to collaborate, and it's powerful. Next thing, training at scale. Next AI allows you to um, operationalize your training scripts, right? It allows you to take each of these um, models that you're working with, pick from them, and then deploy them right there in the UI, right? You can bring your own containers into the environments and make use of Python, TensorFlow to work on them. So, all right, this is where I'm more excited to talk about different options, right? What are the options like have different models of people have? There are three things that I like to consider. First, what can help me deploy simpler? What can I use that I don't have to have so much headache on the infrastructure side of things. So simple deploy. Next thing I like to think of is traffic splitting. If I want to make changes to this model that I'm deploying, if I want to make an edit, if I want to do something with it, will this infrastructure that I'm deploying on allow me to do that without um, endangering the already live one that people are already using? in the case that you deploy this and people are making use of it. And then third, which in some cases you might consider the most important, auto scaling, right? What service or what solution can I use that once the load goes up, my resources go up as well to handle that. I have two options here. First is GA, right? GA for one major reason, which is that allows you to tweak things around, right? Um, there's a certain level of abstraction that GKE can let you reach, but it doesn't take it too far, right? You have a lot of control. You have a lot of, well, I mean, not up to the point of actually touching servers and whatnot, but you have a lot of control, even down to the type of nodes that you're making use of, right? So from the get-go, you can set, oh, this is the type of GPU or CPU that basically using this, how much that could be by the configurations or on the node level. It allows you that flexibility. Um, it also can things on an enterprise level, right? And having things on a very, very large scale, right? Why use GPU for ML? For ML workloads, one, GPU sharing. You have access to things the multi-instance um to maximize the utilization of the resource that you already spun on. Right. Second thing is something called Gray. I don't know if you guys have heard of Gray. It allows you to work with and deploy Python workloads easier. I added a link to that there because I had a feeling that most people might not have heard of Gray yet. You can use Ray both on GK and right there embedded there as well. The next thing is what's autopilot? Autopilot. Autopilot allows so the abstraction I was talking about earlier, right? These fast providers pretty much helping you or able helping you to not worry about things, right? Autopilot is a way of configuring your GA clusters to leave more responsibility for right? For whole cloud, right? So things like going down to nitty-gritty of the configuration of your nodes and all that, you can just leave it to them. Your cluster wants to scale, they're going to handle it for you. The bunch of the networking things that you typically have to worry about when you're configuring a standard cluster, you can leave it to Google to worry about. Although I'm not the biggest fan, just because if I'm using GK, then I might as well have the control that I want to have. Right. Then the second option is Cloud Run. Cloud Run is Google Cloud serverless offering. It's super lightweight, super easy to use, super fast to use as well. And they they allow you to see the evidence of your scaling, right? Either scaling up or scaling down. That's one of the major offerings of Cloud Run. You've not heard it before. Cloud Run is one of my favorite tools just because of the point at which it comes in. Right? So it's cost effective. You pay for the request that you are sending out. It's fast. The point from deploying or deploying the point from having your code written to getting an endpoint that you can actually call is lightning fast, right? It's super easy. It's already set up, right? The infrastructure is already there. It's pretty much just plug and play. Anything that can run in a container, anything that can be put in an image can run on cloud run, right? So all you need to do is make sure that the code that you've written, whatever model that you set up, you deploy it or you package it, same user, or you package it into an image and then bring it to cloud run. Cloud run takes it from there. Then also have GPU support, which is a newer support. I think it's like 8 months, a year old, thereabouts. Allow you to access very large compute power uh, right there in a serverless offering like this. Right. The next, building with generative AI. So in this right AI platform, Vertex AI, you also have the option of doing very cool stuff with Gen AI. Right. So you have direct access to Gemini API, you have access, you can from there go to Vertex AI Studio to very, very, very first one. It's some, yes, sorry, not the very first one, the very third one. Uh, Vertex AI Studio, you can do things right from here. This was set up here, so I'll just put this. Right. The MLOps, machine learning operations, controlling the chaos of your pipelines, your model registry, having a registry of models that you built and the ones that you're working on, and then monitoring each of these models. For pipeline, you have serverless implementation of pipelines, and you have the ability to automate your workflows, right? So if you are for any model that you are working iteratively on, you can set up these pipelines for them so that once you make a change or once any updates, you're working on a new update, you can roll it out, and from the moment that you push it, it's available on whatever endpoints you expose. Next thing, model registry, you have gives you the ability to have a central repository. Maybe maybe I'll just what central repository of the models that you have or are working on. Then third, monitoring, we have the ability to monitor the performance of each of these models and how they are being utilized. Right. So which deployment path should you do it directly with Vertex AI? You take the code you're using, package and deploy it on cloud, or should you do that on GA instead? Whichever way you decide to go, whichever route you decide to go, is still a path of less distance to the typical ways of deployment, right? Because these are made to be convenient. Although once again, just remember, um, these this service, this part of the providers, they feel like there's a certain level that the abstraction can get too much, right? Where now you're working with things and you have no idea how it works in the background, right? You're I mean, so I'm a cloud engineer example. I asked say cloud engineering example. Um, there was this point where we're working with an autopilot process, right? And the autopilot process is we don't have the ability to manage your loads once they've been deployed because it's autopilot. It's going to do all those things for you. Now, if that is a cloud engineer's first point of entry, they don't know what is at the back of it. They don't know that each of these pods, each of these containers that are running on nodes. You can't see each of those things. You can't manage them, right? So it can become over abstracted, right? So that's just something that you need to watch out for, regardless of how much these things make our lives easier. Let me see, jump back. So with Cloud Run, you can have your small models there just for exposing APIs like a core, a very scalable, very the time to deployment is very, very short. The next AI, it's a unified platform. It's one place where you can get access to models, work on models, train these models, import other models and customize it to, work how you want it to work, store it, monitor it, everything, the entire life cycle. The GA, an orchestration service that allows you to manage your workloads in a cluster. All right. So why use cloud AI? So three things to unify, TP, open. So for unified, you could say you have access to a unified platform where you can do all these things in one place. TP advantage, you have access to a lot of power. You have access to a lot of power just there on your console. And then it's open source. So are able to pull in any models that you want to work with. So in Abbott has go cloud and they have their own models that they try to push in place. They also have the option of working with other models right there. Um, yeah, I think I've come to the end. Yeah, that's right. Question, as I've said there, it's not any questions. You have questions now. Yeah, that's just it. So are there any questions?
So we have one uh, question. Please you or yeah, because it's very difficult. So physical. So we have the code ask questions. Um, that's something that's key. So we have one question. Say, how is cloud run Scala ability to serve you?
That's a fantastic question. That's a fantastic question. So unfortunately, because this was not a file engineering section, I didn't go deep into any of these things. So the term serverless on cloud run is a bit of a misnomer in the sense that the name misrepresents what it is, right? So the idea of serverless, right, is not necessarily to tell you that, oh, server separate something, each of these things are running on some crazy compute, right? And then you are getting access to these things on very, very accessible endpoints. However, what they mean when they say serverless is not in, it's not in terms of how it works, but what it allows you to do, right? Which is that it's not that it's not using a server, but that you get to worry about the server less. Right? You get to, you know, so, so you get to worry about the server configuration, setup, the management, um, connections, networking, each of those things. You get to worry about it much less, right? So you're still deploying your workloads on very, very strong computes. Um, these things are going to remain accessible, but get to no worry about that initial setup and that initial configuration. I hope that makes sense.
Okay. The next stuff is I want to do to create some for this person. Uh, to, to create some context here, some some stuff. I'm going to pause and answer that question. Context here, just for because I still use this yesterday. I'll answer that question. Or maybe if you have like a more extra question, you can. Uh, then the next question is traffic. The traffic deployment option same as right.
If you're not answering a question, can you please just press it down for text? Yeah. Yes. Uh, Same as right. Simple deploy. No. So traffic say, okay, I get what you. Uh, yes, it's really not necessarily no. So the term, each of those two things is their terms for different things entirely. For branching, branching, met- branching methodologies or branching technology, look at change management, right? What change has happened, when did it happen, and how can we consolidate those change. Traffic splitting refers to the, the number of requests that you are sending to each version of your deploy more, right? So now it's different from chain management. So chain management is, myself and this man are working on something. He does something. I want to see what he did, pull it, make change on top of that, or I make change before I put it. We can consolidate and whatnot. What traffic sticks in it? Myself and this guy are deploying two different things, right? It's the same endpoint, but two different things, such that say he builds the actual one, the one that's working. Then me, I joined the team, I built the rubbish was old, but then once to test it, we allow school, the container that is running the school, sell traffic to say 90% of our customers, while my own sells to 10%, which means that if 10 people try to hit that same endpoint, nine of them will get the correct thing, right? While only one of them will get my pins. Right. So that's essentially what traffic switching makes you do. That's the difference between that and branching. I hope that makes sense. It does not make sense. But the next one is it. Um, next question. For the mechanics of that, actually, I don't think there is I can't remember right now if there is like, some algorithm that's using. But then, yeah, that's the concept. But it's asking for like, how does it determine who gets what's traffic? There's no like strict order to it. It's just if it's serving 10 requests, it knows that nine of them will be for A, one of them will be for B. Right. So it would be that you send, say, and not necessarily in that order as well, right? Be that you're sending 13 requests. Now, how do you figure out, which one, like, is it going to be 11 and 2, or what? The way it works is like just like that, okay, say I'm serving 100 requests, 90% of them, 90 of those requests are going to go to A. And because of the balance, right? But it's not the same. Like, because I was doing balancing. So I'm getting three requests and I have three servers. Request goes to this guy, goes to this guy, goes to this guy. This guy handling something, I don't send him another one. Right. But then it's still possible that you have three servers, get three requests. First request goes to A, second request goes to B, and then the final third request goes to A is done, and then it sends A request again. Right. So there's no necessary script or that shit. Yeah, is there any other question?
Yeah, one more question.
Yeah, I already away. I said no questions. If I ask any
What's
question.
the best way to determine the best distance? I know things Gemini yeah, I have APIs on text. Just go to the APIs pass and see our desire for yeah. And uh, excellent. I mean, I use it too and do because like I mentioned at example, so this one's
Okay, it's coming in with the question. How do you select which?
to determine the distance of the best distance.
It depends on use case. It always depends on use case, right? It always depends on use case. That's that's my answer. Hey, oh, very good. Oh, very good. I don't have to protect the maps. But why not protect the maps now? Then like, I'm not depend on the use case. It's not a there's no hard and fast rule for this. Say I want to, okay, there's no other fast, but there can be a rule of thumb. Say I want to get something out and fast, I would make it a problem, right? If I want to do something more enterprise wide, say I'm working in a company that's serving a million customers, not because of the control I need to have, because of the reliability that my systems need to have, I could make use of GK, right? Because I want to be more in control of things. But then people, I also know This guy I met earlier this year that works with a bank in the US, like a very big bank, and they were moving from GK to cloud run because they didn't need the control that GK offered. So it always depends on the use case that you have. Just need to know what each of them offers, the trade-offs that each of them have. Cloud run doesn't allow you this level of granular control. GKE does not allow you to move fast. Something doesn't allow you to go as fast as cloud run. Right? Doing things in Vertex AI, you might not have access to some type of configuration. Like you just need to know the trade-offs for each of them. Yeah, whoever asks the question, right? That's okay. And
Yeah, that's regards to so for the person that asked, like I said, what context to put there, they can mix it, and I'm not showing them some of the things I have tried. Um, that's
so the one last thing that I just like to is you are if you are looking to you're looking to try to work these things in a more engaging environment, you can go to C, right? Um it's Google's resource land, right? So here is well the time pushing this is called cloud skills boost. Okay. So the time pushing AI resources a lot more now, right? So they have to take out the cloud skills. So cloud skills of if you're looking for AI resources, you find them here, the learning part. So looking to use AI, to use cloud with your AI resources, you also find stuff like that there. So yeah, we will most of it and thanks a lot, Pedro.
um, yeah, I was that interesting. Was it interesting?